When talking about electrical circuits, there's a few very important things for us to remember. One is, what do our symbols mean and what do they represent? The first part of our electrical circuit is called a resistor. It is represented with a look like this, and it is always a real number. So it will always be represented with something like the A in a complex number. Okay, then you have your inductor, which looks like this. Apologies for my drawings not being perfect. And this is an imaginary number that is positive. That is positive. So it's an imaginary number that is greater than 0. So it will always be represented by BI, positive BI. And the last piece is the capacitor. And in circuit design, it is represented by the double bars. And so that's an imaginary number that is less than 0. So that's what so those together, if you look at the diagram and you look at how many ohms are listed on the diagram, you can determine the impedance of the electrical flow. And then we'll use Ohm's law later to figure out the voltage. Okay, so if I give you a diagram, let's have that up there. Okay, let me draw you a diagram. So this is my diagram of my electrical circuit. I have a 120 volt resistor here. I have 120 volt resistor, 120 volt AC power. Okay, so I'm getting 120 volt AC power. Okay, this is going to be characterized by 3 ohms. Ohms is our measure for impedance in electrical flow. This one is 4 ohms, and this one is going to be 7 ohms. Okay, I can find the individual impedances, and I can also find the total impedances. So for the individual impedance, I'm just going to take it and apply one of these rules to it. So if I'm trying to find the impedance of the resistor, then I find its symbol. So its symbol looks like this. I find its symbol, and since it's 3 ohms, I write it as a real number 3. The inductor, I look for the spring, and then I'm going to write that. I'm going to take that 4 and write it as a positive imaginary number with I. So 4I. 4I. And then the capacitor is the double bars. So since the capacitor has an impedance of 7 ohms, we represent that as an imaginary number less than 0. So it's going to be negative 7I. Negative 7I. So to find our total impedance, those were our individual impedances. To find our total impedance, I just add those up. I add up all 3 numbers. So I get 3 plus 4I plus negative 7I. So 3 doesn't combine with anything else because it's the only real number. 4I plus negative 7I is negative 3I. And so that is the total impedance of my electrical flow. So next we're going to be applying Ohm's law. Next we're going to be applying Ohm's law. Okay, so Ohm's law tells us that voltage, the voltage of a circuit, is going to be your impedance times the circuit, the ampage of the circuit. Okay, so Ohm's law tells us that voltage equals I times Z. V stands for voltage. I stands for circuit, which is in amps. And Z stands for our impedance, which is measured in ohms. Alright, so let's look at the scenario. Okay, in this scenario, we're trying to find the voltage if the current, and I'm sorry, I said this wrong, it's not circuit in amps, it's our current in amps. So that should be our current. If the current is 2 minus I cubed, and the impedance is 5 plus 2I. Okay, so this is my total impedance, so this will be finding the total voltage, not the voltage of an individual piece of the circuit. This will be finding our total voltage. So for our total voltage, I'm going to take the current, 2 minus I cubed, I'm going to multiply it by the impedance of 5 plus 2I. So I have a binomial times a binomial, so I need to make sure I distribute. So 2 times 5 is 10. 2 times 2I is positive 4I. Negative I cubed times 5 is negative 5I cubed. And negative I cubed times 2I is going to be negative 2I to the fourth. Well, right now I don't have any like terms. But I also know that I cubed and I to the fourth can simplify. So remember, our definition of I is the square root of negative 1. So I squared, if I square that value, I get negative 1. I cubed, okay, is now cubing that value, so I'm going to get the I squared times I. Okay, so I cubed is the same as I squared times I. So that's negative 1 times the square root of negative 1, which would be negative I. So that becomes negative I. Okay, and I to the fourth, well, that's I squared times I squared, which is negative 1 times negative 1, which is positive 1. So I get 10 plus 4I minus 5 times I cubed becomes negative I, minus 2, I to the fourth becomes 1. So now 10 and negative 2 times 1 is negative 2. They can combine to become 8. And then that's 4I, and that becomes plus 5I. So now the I terms can combine. So I get a total voltage of 8 plus 9I. Alright, so that's it for today.